Hello everyone, I'm Anna and I'm thrilled to present this video on excitation generator alongside my talented team members Ridwan, Faiz, Jamuna, Fitri and Hemanat. Together, we will present excitation generator in the world of electrical engineering. Excitation generator. An excitation generator is a device that provides an excitation field to an AC generator, which is necessary to produce electrical power. Let's dive deeper into this important tool. The basic. An excitation generator is used to produce the needed electricity for a synchronous machine. How does it work? The generator creates a magnetic field that includes voltage into a stator winding, creating electrical power. There are three types of excitation generator include brushless, static, and rotating exciter, each with its own advantage and disadvantage. Application: an important component for power plants, but also for wind, hydro, or other energy source that require a synchronized power output.
Hi, I'm Jamuna Raja and I'm here today to explain about an excitation generator operation and function. Okay, essential for electrical power generation and extension generation provides DC power produce a magnetic field that is converted into electrical energy by an AC generator. The second one is self-sustaining. An extension generation is also capable of becoming self-sustained, meaning it can generate its own power without any external voltage source. The third is regulation of voltage and frequency. An excitation generation is responsible for the regulation of voltage and frequency, ensuring that the output voltage and frequency remain the constant. And the fourth, prevents voltage drops. An excitation generator also can prevent voltage drops, which can occur when an electrical load is added to a power system. Okay, then I'm going to explain about the components. Okay, the first component here is DC power source. An excitation generator typically has a DC power source, such as a battery or a rectifier, to produce a consistent DC voltage. And the second thing is rotating field. An excitation generation has a rotating field which produces a magnetic field that is necessary for electrical generation. And the third is slip rings. The slip ring is the output of an excitation generator is connected to the rotor field of an DC generator using slip rings. And the fourth is control system. An excitation generator has a control system that regulates the output voltage and frequency of the AC generator. The next, I pass to my team members to continue the.
My name is Muhammad Ridwan and I will continue the presentation with design and maintenance challenge faced when using excitation generators. There are a few obstacles that we will face. One of the few obstacles is the space and weight requirement needed to accommodate the equipment and ventilated areas so that temperature and airflow will help to prevent overheating. Other obstacles such as wear and tear due to a lot of moving parts will add on the overall cost of maintenance for the equipment. The preventive maintenance also need to focus on the build-up contamination such as dust and dirt, which can impact the generator performance. Moving on the next slide, there are a few types of excitation used on Malaysian market such as a brush, brushless, and self-excited excitation generators. There is a pro and cons on every type of excitation generators, with brushless excitation generation provided with less maintenance and increased efficiency, while the brush type is more simple, but less efficient and requires more maintenance. Self-excited excitation generator use methods such as permanent magnet or PMG to convert AC to DC power. It is more efficient but more expensive and complex to maintain. I will pass the next slide to my colleague for further elaboration on the topics.
Assalamualaikum and good evening. My name is Muhammad Fitri bin Abdul Rahman. Today, I would like to discuss control and regulation of excitation. Automatic voltage regulation. AVR system adjusts the excitation to maintain a constant output voltage, regardless of the load. They use feedback from sensor to provide practice control. Okay, next, field flashing technique. Field flashing is used to bootstrap the magnetic field of the generator that has lost its residual magnetic. This can be done by connecting a charged battery or another source of voltage to the field winding. Okay, excitator tester. The excitator tester is the stationary part of the excitator generator that produces the magnetic field, and excitator rotor. The excitator rotor is the rotating part of the generator that carry the DC current and create the magnetic field. Okay, brush. Brush are used to transfer the current from the external circuit to the rotating part of the excitator generator. And the last one is rectifier. The rectifier convert to alternative current, which means AC, produced by the excitator generator into the direct current DC from the rotor field. That's all from me. Thank you.
Hi, I am Hamnat here from FTKE Melaka 2. Today I would like to share about extension generator advantage and disadvantage. So first of all, advantage: extensions generator are reliable, efficient and self-sustaining, meaning they can generate their own power without an external power source. They are also able to regulate the output voltage and frequency and prevent voltage drop when electrical load are added to a power system. Disadvantage: extensions generate can be expensive to install and maintain and require a skilled technician to operate and repair. Then the second one, application. First of all, power generator. Extensions generators are used in power plants to generate electricity from homes and business. And second one, electric motors. Extension generator are used in electric vehicles and other equipment that use electric motors to convert electrical energy to mechanical energy. And third, electrical applications. Extension generators are used in a variety of the industrial application, including oil and gas, chemical processing and mining. Thank you.
For power beyond plants, there are three types, which is wind power, hydropower and transportation. Wind power, the excitation generators are critical in wind turbines for producing the electrical energy needed for the plate pitch system. For the hydropower, there are large hydropower generators rely on excitation generators to create the necessary magnetic field to induce voltage into the stator windings. And for the transportation, the excitation generators are also used in electric trains to power the motors to make them go. So for the summary and concluding remarks, The excitation generators are an essential component of electrical power generation system, providing the consistent DC voltage to produce a magnetic field that is converted into electrical energy by an AC generator. They are reliable, efficient, and self-sustaining, making them ideal for a variety of industrial and commercial applications.